Heisenberg uncertainty principle. Now we are discussing. So we didn't do any mixture kind of thing here. How or well organized it is. So coming to the fourth question. Explain the wave function with mathematical form and discuss the physical significance and the wave function. Okay, so what is a wave function? How it is represented? It is represented by psi. So a physical situation in quantum mechanics is represented by a function. We call it as wave function. Okay, in accounts for the wave function has the properties of the particle. Wave function is obtained by Schrodinger's wave equation. We are going to further discuss about Schrodinger's wave equation. Now how mathematically it is represented? Psi is equal to a into e to the power of I into kx minus omega t. Okay, so what is the physical significance of the wave function? To give the physical significance, probability density. So what it is represented by the psi. So wave function associated with the particle, then delta of psi the whole square is the probability per unit volume or the probability density that the particle will found at the particular given region. Suppose let me say psi as the function and the psi of whole square is nothing but probability function. We can say a probability per unit volume, right? Coming to this thing, Max-Bohr interpretation. If 2 be the value, certain region inside the particle is known to be present, but where exactly it's not known, then the probability of finding the particle, in the element is of the volume. d tau of tau is always equal to the mod of psi the whole square into d tau. For this, the mod of psi the whole square is called the probability density function. Just I've said tau, this thing. The same thing that is Max-Bohr interpretation is also saying. So now, since the probability of the occurrence of an event is real and positive, the psi is complex and no considerable physical significance, so that in order to get the real and positive value of psi the whole square, the wave function is multiplied with its complex conjugate, so that is nothing but the product of psi and psi to the power star. Okay, psi the whole square is represented to get the real and positive real quantity, so it is represented as such. Oh wow, normalization. I love this normalization concept, which made the thing more interesting when I was interviewing about this particular topic. So what is, let's consider a particle. So at certain, is the wave. To give it, I want to find the particle, I want to find the wave function of a small part dx, let me say dx. This is the small position. So how I can represent psi of the whole square into dx. P of x, that is probability of x, is given by the wave function, right? And suppose I want to find, I'll give like this. Even the same explanation is given in the written form, text form here. So I want to find the this thing wave function at this particular region. What I'll do, let me say a and b. A, b. So I can give it as psi, integrations a to b of psi the whole square dx. Isn't it easy? At this particular point I'm taking a and b, right? So integration of a and b, putting upper limit and lower limits along with this thing. I'm just integrating the stuff here. Suppose I want to find the whole thing, minus infinity to infinity. So then what I'll put, integration of infinity minus infinity to infinity. Is it not? Right? So that's what they are giving. If we are certain that the particle is definitely present inside the volume tau, then as per the statistical rule, the integration of 0 to tau, the side of the whole square d tau is equal to 1. Okay, here the value is 1. The probability means it's clear that the particle is certainly present in the volume tau. Let's say this is the thing volume. So in this thing, the particle is present. So we are giving it as d tau, something like that. Okay, the same thing here. Though when it is equal to 1, we can say surely that it is present in the volume. If we are not well all the uncertainty, if you are not all certain about the presence of the particle, if it is finite, then if you are not well, it's not finite, then the particle must exist somewhere in the space. If you are not sure that it's not present in the thing, it will be present. So as I've said, or for finding the thing of the larger things, which is of minus infinity to infinity, it is given by this particular equation.